with IB exams starting really shortly and the NCEA exams starting about the same time, I've been asked to do previous exams, and I don't mind that at all. If you have exams that you want to go over, don't worry about bothering me. You can always email me on calculus.captain@gmail.com, and I'll see what I can do. Any questions anywhere from high school, university, maths, physics, chemistry, I don't mind. I'll at least be able to point you in the right direction, if not do videos on any quizzes or exams that you send through. That said, let's do the 2016 Introduction to Calculus Methods in Solving Problems. Really, it's just calculus with polynomials. And all of the time I'm going to be using my trusty Casio calculator, and that's all I'll be using. I don't think I've done these exams. I may have done them way back in the day, but I certainly don't remember doing them. Okay, a function is given. Function f is given by that. Find the gradient of the graph of the function where x equals 2. So we need to differentiate that function to find the gradient, obviously. So this first term, 4 times 3 is 12. X loses 1, becomes 2. Minus 7 times 2 is minus 14. The x loses 1, becomes a 1. The 2x plus 2x becomes a 2, and the 4 disappears. So f dash, and we put 2 in there. Minus 14 times 2 plus 2. Well, it's going to be 12 times 4 minus 14 times 2 plus 2, and grab the calculator because I'm pretty lazy. So 12 times 4, whoops. 12 times 4 equals 48. Minus 14 times 2 is that. Plus 2 is 22. So the answer is 22, and we could say 22 over 1 really to make it a gradient. All right. The line y equals 3.2x, y equals x plus 3.25 is tangent to the graph of the function there. Use calculus to show that the line is a tangent to the curve, and show that the point where this tangent touches the curve is 0.5, 3.74. And I'm just gonna pause. I need to sneeze. All right, we're back. So when we differentiate that to find the gradient, we find 1. So dy dx for that one equals 1. And when we differentiate this one up here, there's the original function. I'll rewrite it all out. 6x. I wrote that twice. Minus 2. And yes, that's what we've got. So where does this, if one is a tangent, they must have the same gradient. So where does 6x minus 2 have a gradient of 1? Let's move up a bit. So 6x equals 3, x equals half. So that bit is correct. Now do these two lines x equals, so y equals x plus 3.25 and y equals 3x squared minus 2x plus 4. When x equals half, do they have the same value? Well, 0.5, let's kind of lasso this and bring it over, eh? Let's do that and bring it over. X plus, so in other words, half plus 3.25. Does that equal 3 half squared minus 2 times a half plus 4. I recognize I'm running out of space again. Move that down a bit. Wait, I'm just going to pause. All right, so we know already that both of these have tangents, have the same gradient where x equals half. Now, are they in the same place? Well, this one, if we set x equal 0.5, this first one will be 0.5 plus 3.25, and this one here, the second graph down here, will be 3 times 0.5 squared minus 2 0.5 plus 4. So 0.5 plus 0.5 plus 3.25 equals 3.75. And 0.5 for this one. So 0.5 squared, 0.25 times 3 is that, minus 2 times a half is 1, plus 4 equals 3.75. So at these two functions, this one and this one, meet at the point 0.5 comma 3.75 with the same gradient. Therefore, this one must be a tangent to the other one. I think maybe I didn't make that last one clear. So it tells us, I'll do it again in that case. So the line y equals x plus 3.25, and the line f of x is 3x squared minus 2x plus 4. So it says that use calculus to show that the line is tangent to the curve. So that's the line because it says so, and that's a curve obviously because it's got 3x squared etc in it. And the point where they touch the curve, where the line is a tangent to that curve is at this point there. So 3 conditions must be met in order for something to be a tangent. Both first one is that both lines must have the same gradient, and secondly is that they must be at the same point. Okay, and they give us this point -5, 3.75. Okay, the gradient, when we take this first one, y equals x plus 3.25, dy dx is always going to be 1. It's a straight line, so the gradient doesn't change. Okay. Next thing we want to do is we want to establish that this point, -0.5, 3.75 is actually on this line. Well, x plus 3.25, if x was 0.5 plus 3.75 does indeed equal 3.75. So we know that's true. This first line has a slope of 1 and it goes through the line that we're looking for. Second line here. The original function is given as this. So when we differentiate it, we get 6x minus 2. Okay. Does this original line pass through the point 3.75? Well, 3 times 0.5 squared minus 2, 0.5 plus 4. Does that come to 3.75? And let's grab our trusty calculator. 0.5 squared is 0.25. Times that by 3, we get 0.75. Minus 2 times half is -1 plus 4. So we get 3 plus 0.75 is 3.75. So both of these go through this point 0.5, 3.75. Now, do they have the same gradient? We know the gradient for this first one is 1. So let's find this one and insert 0.5 in there to see that the gradient is in fact 1. Okay. So the gradient of this at 0.5 is going to be equal to 6 times 0.5 minus 2. 6 times half is 3 minus 2 is 1. So therefore, same slope in same place. Therefore, tangent. Let's just set up a bit nicer, a bit more logically set out. You don't have to necessarily do that in the exam, but it's just a nicer way, and it's easy for you to understand, I guess. So here we have the equation y equals f of x has the gradient function f dash of x equals 2x minus 1, where a is a constant. The 0.36 is the turning point. So in other words, not only does it go through the 0.36, we know that that's a turning point. Okay, so let's find what a first is. So f dash of x is 2x minus 1, but we know that equals 0 when x equals 3. So 2 times 3, because it says so right up here, minus a equals 0. It looks like a 9. It's an a. 6 minus a equals 0. Minus a equals minus 6, so therefore a must equal 6. So therefore, up here, f of x, f dash of x is going to be equal to 2x minus 6. Okay, and then we want the original function. So we would, it's getting a bit messy, so we would take this function here and we would integrate it. 2 stays there, the x stays there, we get a 2, we divide by 2, the 6 becomes 6x, and don't forget the c, those are going to cancel, so we've got x squared minus 6x plus c. Now we know 2 points. We know 3, 4. So in other words, when x equals 3, y equals 4. So 3 squared minus 6 times 3 plus c, whatever c is, equals 4. Is there something missing? We'll just move it up a little bit. So 3 squared is 9 minus 18 plus c equals 4. C must be equal to 13. So our full function is f of x equals x squared minus 6x minus 13, and we're done. Okay, moving right along. The local minimum value for this function. So let me see, justify your answer. Find the local minimum value for that. First thing, I'm going to get rid of those brackets. Call me funny, but I just like getting rid of those brackets. So x to the power of 4th minus 4 x cubed. It's just a lot easier to deal with when we differentiate and redifferentiate and redifferentiate. So that's our original function, f of x, f dash of x. Therefore, find the turning point is going to be 4x cubed minus 12x squared. And to find the nature of that turning point, we're going to need to differentiate again. So it's going to be 12x squared minus 24x. Okay. So to find what the turning point is, we are going to set that equal to 0 and solve. Now, I can see some simplification. So I can see 4x will come, actually 4x squared will come out of both of those, won't they? And then we're going to have x minus 3 all equals 0. So we're going to have more than one value, aren't we? Okay. We've done the calculus, so let's cheat. I'm going to put that into the polynomial solver and solve it, rather than me messing around. And it is a polynomial solver, and it is a degree 3. So 4x cubed, 0x, whoops, minus 12x squared, 0x, 0 constants, oh, okay, so there's going to be two values, one at 3 and one at 0. Well, there's actually going to be 2 at 0, but 3 and 0 for our point. So now when we take the second derivative and put in 3 for 12 3x minus 24 times 3, is that greater than 0? Is it less than 0? Does it equal 0? Hmm. 12 times 6 minus 24 times 3. I think we may have an answer. 12 times 6 minus 4 times 3, and 12 times 9. 12 times 9. Oh, silly mistake. 12 times 9 equals that, minus 24 times 3 is 36. So that's is less than 36. So therefore it's a minima. And then 0, 12 times 0 minus 24 times 0 is 0, so therefore it's a saddle point. So there. That's what they asked for. Local minima. So the local minima, so the saddle point is not a local minima. So the local minima is x equals 3. And then we would put, I know what this thing is. So therefore there is a local minima at 4 times 27 minus 12 times 9, 0. So therefore there is a local minima at 3, 0. If I've done that wrong, please let me know. I don't mind at all. Now, these ones. So here's the original function. And here is the same function after we've differentiated it. So in other words, it's sloping positive, sloping positive, sloping positive until we get to here. We go down. So it's going to kind of look there like that, and then it's negatively, negatively, negatively sloped until we get to about there. Is about there. And then it, cool. Yeah, and then after that it starts going up again, and then it starts getting steeper and steeper and steeper. It's supposed to look like a parabola. So notice when it's steeper, this is above the y-axis. So this is positive slope. And from here to here, the original function is negatively sloped. And from here onwards, so directly underneath this is where it crosses the x-axis. It's now positively sloped again. We'll do quite a few of those a bit later on, I think. Well, this fills me with all sorts of confidence. Question's been corrected from that used in the examination. All right. Okay, so the line y equals x plus b is tangent to the graph of the function there at the point there. Final values of a and b. Okay. So first thing we need to find the gradient slopes. So for this line, this is going to be a, isn't it? That's going to be the function. And okay. And for this one here, we need to find the gradient function. So y dash of x is going to be 2 times 2 is 4, x minus 3. And y dash of 2 is going to be 8 minus 3, which is 5, positive 5. So therefore, A equals 5. It's a straight line. A is always going to be 5. Okay. So now we need to find A and B for that. If we know it's a tangent, and we know one of the points, 2, 3, and we know the gradient, we can therefore use our little formula y minus y1, can't we? So y minus and y1, I guess, would be minus 3 equals 5x minus 2. So y equals 5x minus 10 plus 3 is minus 7. So therefore B is minus 7. Is minus 7 is, so this graph goes up and then crosses the, like that, and then crosses it at minus 7. Okay. The function f is given by f equals that, where there's an a in there. The gradient of the graph at the point x equals 1 is 3. Find the value of a. Okay. Well, if f of x is 2 minus 4x plus 5x squared plus ax cubed, f dash of x, because we have to find the gradient, so we have to differentiate it. The 2 goes minus 4 plus 10x plus 3 a x, and that's an a x squared. So that's that. And then when they tell us f dash of x of 1 equals 3, okay. So that's going to be equal to minus 4 1 plus 10, and 1 squared is 1 plus 3a equals 3. Okay, so 3 plus 4 minus 10 is minus 3. So 3a equals minus 3. Divide both sides by 3. So a equals negative 1. Strange question, but doable question. A chemist is slowly leaking on the, no, a chemical is slowly leaking on the floor. Although chemists have been known to do that. A chemical spreads out from the point where it lands in a shape that can be modeled by a circle with a radius r. So they drop the chemical there, and then it's kind of ever increasing circles of whatever this thing is. I hope it's not dangerous. At t seconds after the chemical leak is noticed, R is given by 0.1 t plus 2. All right, okay. Use calculus to find the rate of change of area of the circle with respect to time when its radius is 10 centimeters. 10 centimeters. So the area of a circle is pi r squared. Okay. The thing that we wanted to find out, though, there's pi r squared in there. There's no allowing for time, and time is here, isn't it? Okay. We're going to need to do this in chains. So if the area is that, the change in area with respect to the radius, because there is no t in this, we have to do it later, is we're going to have to do, find the rate of change of the circle with respect to time. So we're trying to find dA over dt. Okay. And we know that the area changes with a change of the radius. So the area of the radius, if the area as a function of radius is pi r squared, therefore 2 pi r. Should be an r there. If you can't see it, it's gone off screen. That's better. Times the change in the radius over the change in time. How much is the radius changing in time? And we told here that the radius is given as this. So change in area with respect to radius is 2 pi r. The change of radius with respect to time is going to be this differentiated, which is going to be 0.1. Because if r equals 0.1 t plus 2, when we differentiate, change in r over change in t, it's just going to be 0.1. It's just going to get 0.1 something, and this t is irrelevant. That must be the original spell. Okay. So dA over dr, we already worked that out as 2 pi r, and the change in radius with respect to time is 0.1. So therefore the change in the area is going to be 0.2 pi r, isn't it? We combine both of those. The dRs will cancel, and we're left with dA over dt, which is what we're trying to work out in the first place. So the question then is, what is the use calculus, find the rate of the change in area of the circle of this toxic fluid with respect to time when its radius is 10. So 0.2 times pi times 10. So 0.2 times 10 is 2, which is 2 pi, which is approximately 6.28 centimeters per second. No, not per second, just per second. So it's going to be 6.28 centimeters cubed per second. Yeah, that's going to be the volume. 2 pi, if we take pi as meaning 3.14, roughly 2.28 cubic centimeters. Cubic centimeters? No, it's going to be square centimeters. Square centimeters because it's going flat along the surface. Yeah, 6.28 square centimeters per second, increasing. So, depending on what that is, clean it up. Always clean up after you and report if anything toxic has been fallen on the floor. Right, next question. This is a bit of an odd one. So it's going to be a parabola. So a function is defined 3x cubed minus 4a squared x plus 5, where a is a positive number. Okay. A is a positive number. Find the range of values in x for which the function is decreasing. So we need to differentiate it first. So if the function of x is 3x cubed minus 4a, and a is positive number, so a squared is also a positive number. And then we need to differentiate it because we need to find where it's increasing or decreasing. Minus 4a squared, the x goes, 5 goes. And because we know that it's decreasing, that means it must be less than 0. And that is a negative sign, and a is positive. Equals. Okay. I don't know about you, but that looks like a difference of 2 squares to me. 3x plus 2a, 3x minus 2a. And it's going to help us because one of them is always going to be positive and one of them is always going to be negative if they're both less than 0 and a is positive. So let's set 3x plus 2a equal to 0. 3x equals 2a. X must be equal to 3a. Sorry, 2a over 3. And that's going to be a positive number. Okay. Now parabola is going to kind of look like that. So that's going to be the upper end. Now let's do it to the same for this one. So we're finding the two ends, and we know now this must be the upper end. So 3x equals this is minus 2a, wasn't it? Minus 2a, because we took 2a away from both sides. So that's got to be negative. So that's got to be negative. And x here is 2a over 3. Those are all positive numbers. So that must be a positive number. So therefore, it's decreasing when between minus 2a over 3 and positive 2a over 3. There's our answer. Yeah. Oh, tough for a level 2, but okay. Okay, this one is fairly common. You should know how to do these. We start off with dy dx, dy over dx equals 3x squared minus 5. We know that it passes through the point 1, 2. We want it back equals y equals something. So if we're told that dy dx is 3x squared minus 5, then when we come to integrate it, 3 stays there, the x stays there, the 3 picks up a 3, the 2 picks up a 3, and then we have to divide by that, minus 5x plus c. Those 3's are going to cancel, so y is going to equal 3 cubed minus 5x plus c, and we're told that 1, 0 lies on that original curve. So in other words, wherever we have an x, we're going to have 1. Wherever we have a y, we're going to have 0. So 0 equals 1 cubed minus 5 times 1 plus c. So 0 equals 1 cubed is 1, minus 5 times 1 is 5, plus c minus 4 plus c equals 0. Therefore c equals 4. So our original function, we were given dy dx, so it helps to offer back our final answer, x cubed minus 5x plus 4, and we're done. All right, so this one is sort of the opposite of the similar one that we had before. So this one is f dash of x, and this one is the original equation. So for this one here, from here to here, this graph must be sort of positively sloping, and then getting less and less slopey. And then from here to here, it's negatively sloped. So it's gonna get more and more and more and more and more negatively sloped, and then it's going to become less negatively sloped, and then when it crosses the x-axis there, from everywhere onwards from here, it's going to become positively sloped, and more and more and more positively sloped. So it's going to kind of look like that. Again, I'm not an artist. Okay, Meg is riding her motorbike, her motocross bike. She passes a fixed point P on the track. She has a speed of 5 meters per second. And her acceleration A is 0.6 meters per second. If she were to continue to accelerate at this rate, what is her speed when she has been riding for 10 seconds? Okay, so we've got her initial, we've got her acceleration is 0.6 meters per second squared, and we've got her initial velocity at 5. So remember, when we go from acceleration to velocity, we go up the ladder, and when we go up the ladder, we integrate. Okay, so we're going to take this number. Her acceleration is 0.06. We can ignore the units in this case. So acceleration is 0.6. When we integrate that with respect to time, we get 0.6 t, and that's going to be equal to v. What's the plus c? Plus c is going to be 5, because that's the initial condition. So when we integrate acceleration with respect to time, we get a velocity with respect to time plus the initial velocity. So her velocity at 10, so her velocity at any time really is going to be 0.6 t plus 5, which is going to be 0.6 times 10 plus 5. 0.6 times 10 is 6 plus 5, so it's going to be 11 meters per second. That's going to be her velocity after 10 seconds. It says, what is her speed? So we're not going to confuse speed and velocity. We're going to take speed as being her velocity. It doesn't say that she's swerving all over the road, so we're going to say that that's her speed is her velocity. How far will it take? How far will she have traveled from P when she reaches a speed of 8 meters per second? Excellent question. So for her to be at 8 meters per second, I guess we would solve this equation, 0.6 t plus 5, and we set that equal to 8 and solve for t. So 0.6 t equals 3. We took 5 away from both sides. T is going to be equal to 3 over 0.6, which is, grab the trusty calculator, 3 divided by 0.6 is 5 seconds. Okay, how far will she have traveled? Well, she is not traveling. She's traveled nowhere when at time 0. So after 5 seconds, we've got velocity with respect to time. To go from acceleration to velocity, we integrate to get from velocity to displacement, i.e. the amount of distance this traveled in a straight line. We integrate again. So our function velocity with respect to time was vt plus 5, because that was our initial value. Therefore, the displacement at t is the vt 0.6 t plus 5. That's better. So when we do that, the 0.6 is going to stay there. The t is going to stay there. It's going to gain 1. We're going to divide by 2 plus 5 times t. If you really want, we can divide that by 1. And now the c is 0 because she hasn't covered any time at time equals 0. So I'm happy with that. Let's rewrite that just so it's a bit clearer. So the velocity at any time, the amount traveled at any time is going to be 0.3 t squared plus 5 t. Yes. That's that. And then we set t equal to 5. So the displacement after 5 seconds is going to be 0.3 times 5 squared, which is 25, plus 5 times 5. And we'll grab the calculator. 5 times 5 is 25 times 0.3 equals 7.5 plus 25, 32.5 meters. Meg's friend Leo was riding with her, but he begins to decelerate when they reach a speed of 8 meters per second. If he decelerates at 0.2 meters per second, how far past the point will he be when he reaches a speed of 6 meters per second? Okay, so for this one, Meg's friend Leo's riding with her, but he begins to decelerate when they reach a speed of 8 meters per second. So I guess he was going 5 and then sped up or slowed down. So he covered a distance of 32.5 meters. And we're really saying that his initial velocity was, from when he starts slowing down, was 8 meters per second for us. So this is the initial distance. But how far past the point when he reaches a speed of 6 seconds? Okay, so his velocity at any time will be equal to 8 minus 0.2 times the number of seconds. Yes. So we want to find out how much time will have elapsed when he reaches 6 meters per second. Okay. So minus 2. Divide both sides by that. So he will reach 6 meters per second after 10 seconds. Okay. So what is the distance that he moves at that speed? Okay, so V naught is 8, and if we integrated that, we could find out. So his acceleration is 0.2. That's acceleration. Taking 10 seconds. So therefore, when his velocity is going to be 8 minus 0.2 t, because that's the initial velocity. And then we want to work out how far he's gone. So I guess we're going to be integrating that again. So it's going to be 8t minus 8t squared over 4. No, 8t minus 0.2 t squared over 2. And the t is going to be 10 seconds. Yeah, I just checked. Yes, all my algebra is correct. So 8 times 10 minus 0.2 10 squared over 2. So that's going to be 80 minus 10 equals 70 meters. First I saw that, I thought, that can't be right. Must be less than that. But I just checked. I cheated. And yeah, that is actually true. So he goes for another 70 meters. So even though he's slowing down, he's still moving forward. He's moving quite quick. 8 meters per second in a moped. Ooh, that's pretty quick. A bit quick for me anyway. Just quietly. Okay, so that's the 2016 calculus, beginning calculus, intro to calculus for year 12 students. And I'll do the 2018, 19, 20, 21, 22, 23, 24 if I can get my hands on them. Again, any questions, email them through. I'll be happy to read anything you have to say. Okay.